Hey everybody, how you doing? Word to your mom, I'm Chili, and today I've got a funky fresh C++ topic for you. Today we're gonna be doing a little stuff with thread synchronization, multi-threading bullshit, which is always fun. I'm gonna try to keep this one short and sweet. The topic is condition variable. And I'm gonna tell you what it is, how you do what you do, and then I'm gonna give you an example of how that might be used. But before that, let's do a quick little review here. So I talked about mutexes in, I guess it's the episode on X Audio 2. Because in X Audio 2, you've got the callback that gets called by a different thread. So you have to handle synchronization between that thread and, the main thread of your program. And basically the way that a mutex works is it protects data that is going to be shared between threads, that's accessed by more than one thread, possibly at the same time. Obviously, if they're never accessed at the same time, you might be able to get away with not using a mutex, but in general, you're going to have to use a mutex, and the way it works is, if thread 1 is going to call this function f1, it's going to acquire the mutex. It's going to create a lock object, and that lock object is going to acquire the mutex. And then the body of the function can access the data. And when you leave the function, the lock object is destroyed, and you release the mutex. Now, while thread 1 is doing its magic bullshit here, let's say thread 2 also calls function 2. That function tries to create a lock on the mutex, but, function 1, or thread 1, already owns the mutex. So when thread 2 tries to lock the mutex, it blocks here. Block. It gets cock blocked. It gets thread blocked. And it has to wait until thread 1 releases the mutex, and then thread 2 can continue on here and access the shared data. And when it's done, it releases the mutex, and everyone's happy. So you got some shared data, and if you got some shared data, you need to protect it with a mutex. Similar situation you can see here. Same deal. You got multiple threads. They are all accessing the same data. In this case, they're all calling the same function, which is fine. The same function can be called from a bunch of different threads. It doesn't make any difference. And it's the same thing. You lock the mutex and you access the data. So if thread 1, let's say thread 2 gets enters F1 first, it gets the lock. And now it has the lock and it can access. And if thread 1 tries to call F1, it's going to block here. And then when thread 2 leaves, it's going to release the mutex, and now thread 1 gets the mutex and it can enter. Same difference, right? That's how a mutex works. This is nothing new, hopefully, if you've seen the X Audio 2 episode. So, condition variable. Well, first of all, the thing about mutexes is they basically provide a way for threads to compete with each other, for threads to, basically exclude each other, right? Mutex, mutual exclusion. So this is threads competing with each other, kind of pushing each other out of the way. No, me first. You get out. You wait until I'm done. No coming in the bathroom when I'm still taking a dump. That's weird. It's basically how it works. But what we kind of want is we don't have a way for threads to cooperate. Here they're just kind of, pushing each other out of the way, getting on each other's nerves, fucking each other's steves up. And what we want is a way for them to cooperate. They have to communicate with each other. And that's what the condition variable gives us. It gives us a way for one thread to signal another thread. Or looking at another way, you can have threads wait on a certain signal. And that's a good thing. But we'll get into why that's good in a little while. Let's just go over what we need. So you need a condition variable. You need a mutex. You need a unique lock. You can't use a lock guard like we've been using, and I'll get to that why. And you need some kind of shared memory, and that is where the data is going to be passed between the threads. Sometimes you could probably get away with not using shared memory, but in general, you're going to need that. You're going to need some kind of shared memory in some aspect. So that's what you need. Now, how does a conditional variable work? I keep saying it wrong. Shut up, Photoshop. No one likes you. Okay, so the first thing you need to do, like I said, you need a lock. You need a mutex, and you need a lock. First thing you do, you lock the mutex. Once you have your locked mutex, you're going to call a function on the conditional variable called wait, and you're going to pass it the lock. And when you pass the locked lock, which is locking the mutex, wait is going to release that mutex, and it's going to block your thread. So calling wait is saying, okay, I'm going to wait here, and I want you to wake me up inside can'twakeup.gif. And then this thread is going to be waiting. It's going to be sitting there. It's not going to be consuming any CPU cycles. The operating system isn't going to schedule this thread. It's just going to suspend the thread. And it's going to do that until a different thread first acquires the mutex, either via a lock, or it doesn't matter how you acquire it, but you get the mutex. You then have to modify some shared memory. Again, you might not have to do this, but in general is what you're going to do. You're going to get the mutex, change some memory, release the mutex, and then call the notify function on the same condition variable that was used to wait. And that is going to wake up the first thread here. It's going to wake it up. And when the thread wakes, it's automatically going to take that mutex again. And then it's going to check the condition. It's going to check this shared memory to see whether or not it's, time to go. And if the condition is true, if this shared memory passes some test, then we continue on. Otherwise, we release the mutex and we go back to sleep. So that's the general flow. Now that might not make much sense because, it's just a bunch of words that Chili has spat out at you from the interwebs. So what we need is some code to show this in a little more concrete fashion. So what we're going to do is we're going to sync up the HUGS with GitHub. And we're going to say, hurry up, you motherfucker. Receiving, I don't even know why there are 8 objects, but anyways, so we sync that up, and then we go to branches, new branch, and we're going to go down here to condivar. That's our condition variable branch. Create that. And let's take a look at what has changed. Well, we go here. We go to changes. We go actions, view history, and condition variables for the win. Coming at you with the hot dank. Wait, where's the... Yeah, let's do that. Dank 2013 memes. I don't know when that's from. That's whatever. Is that even a meme? Doesn't matter. So what are we doing here? Well, if you remember, it hasn't been that long since we looked at this part of the code. This is in the sound class, by the way. The X Audio 2 code. So we've got a sound that basically wraps a buffer of samples, basically a wave file, the samples from a wave file. And it wraps them up. And what we want to do is we want to destroy that sound. We want to free up that memory. So the first thing we do is we stop all of the channels that are playing the sound. And then we wait until the channels are actually all deactivated. Because it's this stop all, well, it calls this function, which calls pchannel.stop. Now this is asynchronous. So this, if you call stop, the thread that is playing the sound doesn't automatically stop, doesn't instantaneously stop. You send that message and it will stop when it fucking damn well pleases. So you can't just assume that all those things have stopped. And you don't want to destroy this memory. Where is it? The memory pointed at by here, actually. You don't want to destroy this memory if there's a thread that's still trying to read that memory. That's not going to be a good time. So what you do is, well, what we're doing here is we check to see if the number of active channel pointers has reached 0. In other words, if all of the worker threads have stopped playing this song or this sound. And so we get that Boolean, we calculate that Boolean, and then we keep looping, checking to see whether or not that is that's true, whether or not all the channels have become deactivated. And that's fine. Now you have to, because the where is it? Because the vector here, active channel pointers, is shared between the sound object and the worker threads. You've got to lock a mutex before you check that shit, before you access that shared memory. So what we're doing is we're spinning here, we're spinning our wheels, repeatedly locking, checking, and unlocking a mutex. And that consumes a lot of cycles of a CPU core. So what I did was I added this yield in here to make us spin not so hard. So the first thing you do is you wait a bit. You tell the operating system, I'm not that busy, I'm not that urgent. You can put me to the back of the queue. And then when your time comes up, you lock the mutex, you check the variable, and then if you're not done, then you loop again and you tell the OS, okay, you can put me at the back of the queue again. I'm good for a while. And that's how we did that. But you're still spinning and you're still consuming cycles that you might not need to. Now, how would we solve this problem with the old condition variable that Chili has just described? And it's quite simple. You do the steps that I just told you. So first off, you create a unique lock on the mutex here, or on the mutex. So you lock the mutex, and then you're gonna check to see if the channel pointers are already are they just empty from the start? Because if they're empty from the start, you might as well just return right now and save yourself some time. Actually, this is really important. I'll get to that later. So first you check to see if you're already done. If you're not already done, well, then it's time to call stop on all of the active channel pointers. Get that message out there. And once you've called stop on all of them, then you call wait on this condition variable, cvDeath. So you see down here, we've added one piece of one variable to this class, and it is the condition variable, cvDeath. And so we're going to wait on cvDeath, and you pass it the lock that you used to lock the mutex. It has to be a locked lock. It has to have a mutex associated with it. You can't try to pass it an unlocked lock, or you can't call this function without a lock. You need a mutex and you need a lock in order to use a condition variable. There's no way around that. And then in here, this is optional, by the way. You don't have to do this, but you can pass it a function, a predicate function that returns bool, and that function will be the function to check the condition variable. So when this thread wakes up, the first thing it's going to do is it's going to call this function, and the function is just, check to see if the active channels is 0. And if it is 0, then we continue. But if it's not 0, this function returns false, and this condition variable, it releases the mutex again, it unlocks it, and it goes back to sleep. So that's all you need to do, really, to use the condition variables on this side. Now, this is the waiting side of the condition variable, but you also have the notifying side, and that comes in here. So the function remove channel is called, let me see here. Oh shit, I can't check the other thing. All right, you can be like that, you little bitch. We're going to go to sound.cpp. All right, so what do we got here? So when you stop a buffer and you call flush on it, this function here, by the way, go to definition. So when you call stop on a channel, it stops the source from playing and it flushes the buffer. And when you flush the buffer, what's going to happen is it's going to call on buffer end. And on buffer end, it calls stop, which again flushes the buffer. It doesn't matter. If you flush an already flushed buffer, nothing bad happens. It just returns really fast. And then it calls remove channel. And here is where the magic happens. First, you acquire the mutex. So you make sure that, this thread is, for example, it's not in here fucking around with anything. It's not checking the active channel pointer size while you're racing things. You make sure that, it's either waiting, where it's released the lock, or it's not even in the destructor. So you get the lock, and then you erase the channel, your channel, and then you call notify all. And notify all will tell, for example, if the other thread is waiting on the condition variable, it's going to wake that thread up. And what that's going to do then is when this thread wakes up, it's going to try to acquire the mutex. And if this one still holds the mutex, it's going to block first. But if this one has already left, it's not even going to block. It's just going to get the mutex. Then it's going to call this function, which checks the active channel pointer size and sees if it is now 0. And if there are still active channels left, it's going to go back to sleep. Or if there are not active channel pointers left, then it's going to leave. And that's it. So you call remove channel, notifies anyone waiting on this condition variable that the number of channels has, changed, it's gone down, and maybe you should check that shit. And then if the other thread is in the destructor and waiting on that, it's going to wake up and check that shit. And that's it. Now, the beauty of this situation here, if you haven't gotten it yet, is of course, in this one, you've got a single thread, a single core that is just thrashing this loop. Well, we got the yield in here. It's a little better, but it's still thrashing this loop, and it's still consuming a lot of cycles. But in this one, this thread, it just does its work. It stops all the channels, sends the stop signal, and then it just waits. And so it's not thrashing. It's doing nothing. It's just sitting suspended, waiting for a notification. And so it's not consuming any useless cycles. It's very efficient. And that is the beauty. That's the difference between this and this. Here, you're wasting a core spinning your wheels. Here, that core is available to process some other code. Now, a couple of little interesting points here. First of all, this check for the active channel pointers here before you enter the wait loop is very important. Think about it. Think about this. What happens if we call the destructor on a sound, but it's currently not being played anywhere? Well, we get the mutex, and let's say we don't do this check, and so we call stop on all of the channels, which is none. There are no channels active, so we don't enter this. We skip past this, and then we wait for a notification. Except there are no channels that are there to die. So when we wait on this notification, we'll just be waiting forever. I don't know actually if it could not be true. I haven't tested this, but I suppose it's possible that the condition variable, when you call wait, it checks the condition before you enter the wait loop. I'm not sure. I don't think that's the case, but either way, it's a good idea to make sure you check to see if there are no active channels before you wait. Because here, we're waiting for a message that will never come because there are no channels to die. There are no channels to call remove channel. And so this wait will never get the message. It'll just be sitting there forever, suspended forever. It's not good. It's not the end of the world, but it's not a good scene. Actually, it's really bad because this thread is probably our main thread, and if it blocks here, it's just gonna spin its wheels forever. Now, I haven't seen it do that, but in any rate, it's just not a good idea. You wanna, if you don't have any channels that have to die, then just return right away and don't do all this bullshit. Forgo the bullshit. That's what I'm saying. Now, this is not the only way to do this. You can call wait. Well, I can't modify this code, but I can modify this code. So you can call wait without any predicate. And so you're just going to wait for that. Now that's not a good idea because, I mean, you could get a notification for the first thread that dies, and then you'll just leave and destroy the memory before the other worker threads have stopped playing the song. So that's not a good idea. But what you could do is you could go something like this. My freaking keyboard is in Japanese mode here. Do cvdeath.wait lock while, and then you put your condition in here, right? While active channel pointers dot size not equal to 0. So this works fine too. And if you change this to a standard while loop, then you don't really need this one here. Now I'm not sure. Let's do a test here for shits and giggles. This is a short episode anyways. Let's do a little fucking test here. So let's go back to the do loop here. Do this while blah. And let's get rid of this. Now, if I'm correct, if we try to destroy a sound that is currently not being played, the program should freeze. Because we're going to wait for a signal that will never come. So here we go. Yep, it froze here. Even though I don't even recall friggin' loading any sounds in this. Apparently I loaded some sounds, and those sounds have frozen the shit out of my program. So, what this means is that, let's go back here for a second. We just learned something about condition variable. Go back to this. So what that means is that this cvdeath.wait, if you pass it a predicate, it will test the predicate before it goes to sleep, which is good, I guess, and also good to know. Yeah, that works. Okay, so that's good. You don't have to worry about testing the predicate before you go to sleep. It'll test it beforehand, just in case. So this technically isn't even really needed. Doesn't hurt, but I mean, it's not as necessary as I thought it was at first. Now, what else? Of course, you could still get that to work by doing it a little different. All you'd have to do is you do while blah blah cvdeath.wait lock. And while this is not equal to 0, so this should work and it shouldn't freeze. Because, the reason why is because we do the test before we wait. So yeah, it works fine. So if you're testing, or if you're going to use wait without a predicate, you may remember, you want to, in some way, you want to probably test that condition first. Depends on your usage, your mileage may vary, but that's just something to keep in mind. Now, we could do a little better here. It's not a big deal. This is not a performance critical section of the code. This is a destructure. It's probably going to happen, you know, in a scene transition. We're not worried about the performance here, but for illustration purposes, I just like to show how we can do a little better. And what I would do is what we're doing is every time a channel ends, we're calling notify all. But we don't really need to do that, do we? What if we do this? Copy this. If blah, then notify all. Now we only bother the waiting thread if we know that the channel pointers.size is greater or is equal to 0. Then we wake that thread up. Otherwise, we just leave it the fuck alone. We say, you know what, dude, you've earned it. You can have a nice sleep there. And that's a good thing to do, I think. Now what else? What else did I want to do? Right. Okay, so one thing that I wanted to talk about here is normally we use a lock guard. But here we have to use a unique lock. Why is that? Well, a lock guard is a very simple lock, and all it does is it acquires the mutex until it dies. You can't get that mutex from it until you pry it from its cold, dead hands. And that doesn't fly for a condition variable, because in a condition variable, you need to have a lock that is unlockable. So you acquire the lock here, but when you call wait, the condition variable releases the lock, and it automatically acquires the lock when it wakes up again. So you have to have a lock that is able to be unlocked, and that is not possible with lock guard. Look, lock guard, lock dot, and you only get an assignment operator and a destructor. But with unique lock, you get a whole bunch of bullshit. One of the bullshits that you get. Wait, lock dot. Wait, that wasn't okay. Don't never mind that. That was just me fucking up. You still get some bullshit. You get a lock function. You get a release function. You get an unlock function. I don't know the difference between unlock and release. I'm going to be honest with you. But I think release probably releases the mutex from the lock, whereas unlock unlocks the mutex. So release removes the association between this lock and this mutex. And I'm seriously just pulling this information out of my ash. I don't actually know. I didn't look it up. Also, I pulled it out of my ash. But anyways, so you got a whole bunch of different bullshit here that you can do. It's not important. The important thing is that you can unlock this mutex with a unique lock, and you can't do that with a lock guard. And that is why unique lock is needed for the condition variable. Now, there is one more thing that we could do here to make this a little better. Notice that here we call notify all, but we're still holding the mutex because we hold that mutex until the end of the scope here, until this lock guard dies. And that's not so good because when we call notify all, this thread's going to wake up and it's going to try to acquire the mutex, but the mutex is still held by the thread here. So what's going to happen is this one is going to wake up and it's going to immediately block. And blocking, when you try to acquire a mutex and you fail and you block, that it wastes a lot of time. It's a bad news bears. So here, what we actually want to do, and it's often the case, what you actually want to do here is you want to call, first you want to turn this into a unique lock. And then here, so if channel pointers.size is equal to 0u, and we're still holding the lock when we make this test because we want to make the test under the lock. under the mutex. We don't want anyone else fucking with our data when we're testing it. And then we see, okay, active channel pointers is equal to 0. Then what you can do is you can call lock.unlock. Unlock that mutex first, then call notify. Then this guy, when he wakes up, he can get that lock immediately. There's no delay, there's no wasted time, and it's just smoother, it's faster. And then, yeah, and then we just leave. So unlock before you call the notification. Sometimes you want to hold that lock, call notify, and then unlock. There are some situations where you might want to do that. You don't want any gap between this thread releasing the lock and this thread releasing the mutex and this thread acquiring the mutex. Maybe there's some situations where you don't want a gap, but here it's fine. Just unlock that shit and then call notify. Now, last thing, you might be saying, well, Chili, I mean, you don't really need here even to check. You don't even need to check this. You can just wait, and or you can do an if. So you can say if this is equal to 0, return. Otherwise, just wait on the lock, because you're only going to get a message when the last channel has been removed. So when you get, the only time you're going to get this message is when this is equal to 0. So why do you need to test it when you wake up? And the answer is for condition variables, and it varies depending on operating system, but there is something called a spurious wake up. And that is when, even though there has been no notification, a thread will just wake up, just like, you know, like out of a random coma or something. You expect that dude to be sleeping there like a vegetable, and he just wakes up one day and he's like, holy shit, I didn't expect that. So that's what happens. It's called a spurious wake up. And that is why, even when you don't think you need to check a condition, you should still check the condition, because the wake up might not have been because of a notification. It might have been because of a spurious wake up. So you do this. Or the sexier way to do this is obviously to, use the, what is it called? The predicate. Use the predicate, it's sexy. I was just showing you some other way of doing it here. But yeah, in this side, this is actually sexier than what I had before. It's not a big deal. I'm not going to worry about it. But I was just wanted to show you. In a more performance critical situation, it might make a big difference whether or not you, for example, unlock before you call notify, or whether you call notify for every event or only for the final event that is going to trigger the condition. But that's it. That is all Chili has to say about the motherfucking condition variable. Now, I'm planning, this is part 1 of what I'm thinking of doing as a 3-part series. So part 1 was condition variables. Part 2, I am going to implement a communication synchronization between I don't think I spelled that right. I don't know why I think my brain thought that was going to be good. So synchronization between a worker thread and a boss thread. And this is going to be done using, the theme is going to be MIDI. So we're going to make a little MIDI player worker thread that's going to play MIDI music for us. And that is going to show a little more sophistication to using the condition variables. And part 3, it's also going to show us how do we create our own threads. So launch threads. And part 3, we're going to multi-thread the Bloom engine a little bit. we're going to see how to use multi-threading in to improve the performance of some performance critical code. So that's my brainchild. That's my idea here. So this is part 1 is done. We've talked about the condition variable. Part 2, we'll make a dumb MIDI player, and part 3 will accelerate Bloom with multi-threading. Now, what I want to know is, are you guys interested in this bullshit, or do you just want me to skip this bullshit? Because I can skip this bullshit if you want. I might do the MIDI player anyways, but I just won't make a thing of it. I'll just kind of add it as a side note, because it's not that important. But if you guys are interested in multi-threading, then I will definitely put this stuff in there. But that's up to you. So if you like this video, like the video, and also let me know if you want to do part 2 and part 3, or you just want to skip it. And that's it for today. I will talk to you later.